Hey guys, how's it going? I hope your day is going well. Welcome to the last lesson in this summer session, and we're going to be talking about rates of change as represented as slope. Let's get into it. What is a rate? Nice little spin move. All right, so a rate is basically a ratio that compares two numbers with two different units. Let's say this again. A rate is a ratio that compares two numbers with two different units of measure. Okay? Example. It says that Ashley receives about 33 text messages in 8 hours between 8 and 4 p.m. There's our two different units, text messages in 8 hours. What is Ashley's message rate? How do we find and write the rate? So to express the rate, we want to write it as units of a ratio over the units of the denominator. First, let's identify the units. And I just said that we're talking about text messages and we're talking about hours. FYI, anytime you see hours, guys, that's going to be on the bottom of the ratio. Anytime you see time, any measurement of time is going to be on the bottom of the ratio. All right, let me say that one more time. Anytime you see any measurement of time, hours, seconds, minutes, that's all going to be on the bottom of the ratio. That's just a little nugget that I'm handing out. Let's keep it pushing. So how do we find the rate? So second, we write the units as a ratio. In a ratio, we set it up as a fraction. We know that she got 33 text messages, and we know that that happened in 8 hours. Text messages is going to go on top, and I just told you guys that anytime you see a measurement of time, it goes on the bottom, which is hours. So how do we find the rate? We're going to insert the units, the text messages. How many of them was it? 33. Hours, 8. So what is the rate? Well, our rate is at 33 to 8. I thought I was going to simplify. Things to remember. A rate is a ratio that compares the quantity of one unit to a second in a different unit. The rate is written as a ratio between quantities as a fraction of one unit over the second unit. Basically the numerator over the denominator. What is a unit rate? A unit rate is a rate with a denominator of 1. The unit rates are what we see in everyday life. All right? Can you think of some unit rates? We got some examples here. Miles. Miles per hour. How many miles are we going to drive in 1 hour? Because we said the denominator is going to be 1. Calories per serving. How many calories are we going to get per serving? What is per serving? Per 1 serving. What we got next? Dollars per pound. Anytime you have an expression of money, that's going to be on the top of the ratio. Minutes per mile. Okay? These are all examples that we see every day. So how do we create the unit rate? Let's go back to our example with Ashley. We got 33 over 8. And remember, we said that anytime you have a fraction, it is basically a division problem. So we end up with 33 divided by 8, which gives us 4.125 units per 1, right? So it is at a rate of, she's basically sending 4.125 text messages per minute or per hour. She texts them real slow, basically. I'm not going through all of this, man. We get all that. I've said all of that. If you guys got questions, hit me in the Google Classroom or email me. Exploring rates as a slope. What's the difference between the rate of change and the slope? Listen, man, there ain't no difference. They the same thing. If you in my class, you know that I taught y'all that the unit rate is basically a synonym for the slope. Slope generally refers to the steepness of a line or the steepness of a graph. So the slope is comparing the change in the vertical distance to the change in the horizontal distance between 2 points on a line. Okay, change in the vertical distance, that's the change in the y, over the change in the horizontal distance, which is a change in the x. This lingo should be familiar to you guys already. Let's keep it pushing. What is the vertical? Okay, the vertical, when we work this, we define the vertical as the rise, and we define the horizontal as the run. Okay, so we're not going to do that. So making the slope into a formula, all right? Our change in y, that is a rise of 3. And it is a run of 5. So if we're doing rise over run, because I don't think they're gonna hit us with this. They're not gonna hit us with this. So the vertical distance is basically, I'm gonna talk about the rise over run in just a second. Be patient with me. The vertical distance basically is this. You have y2 minus y1, the vertical change. The change in y over the first point versus the change in y of the second point. Y2 minus y1 over x2 minus x1. That's our slope formula. You guys know that. If you're in my class, I taught you that you can find this slope using the slope formula, which would have been, see, this is still talking. Okay, here we go. So here's the actual slope formula. Okay, there's two ways that you can find the slope on the graph of a line. You can use the formula y2 minus y1 over x2 minus x1, which is what you see here. The y2, which is 3, minus 0 over 5, which is the x2, minus the x1 of 0. Right? 3 minus 0 is 0. I'm sorry, 3 minus 0 is 3. 5 minus 0 is 5. Therefore, making the slope 3/5. Now, the rise over run, basically you're calculating, or not even calculating, you're counting how many units am I going up. It's very simple. I'm rising 3 units. The rise is the one that goes up. You rise up. When you get up in the morning and you rise in the morning, you rise up. Rise is going up. It's a vertical measurement. So the rise over run, the rise would be how many units am I going up or down? And that's 3. The run, rise over, fraction bar, run, you run straight, horizontal, right? How many units are we running? That is the 5. I'm basically showing you 2 different ways of calculating this. I showed you using the slope formula just a second ago. Now I'm talking about the rise over run. I want to make sure that's clear for you guys. The rise over run, there we go, 3/5. All right, here we go. Let's go here. Representing, having a little bit of technical difficulties. That's all right, we're going to keep it pushing. All right, so let's break this down little by little as we go along. So it says Max can eat 15 hot dogs in 9 minutes. Let's look at our units. What would the units be in this problem? The units would be 15 hot dogs in 9 minutes. The slope would be 15 over 9. Remember I told you guys anytime you see time, that time is going to be at the bottom of the ratio. So when we talk about our rate would be 15 divided by 9, which gives you 1.6 repeating. So the rate would be 1.6 repeating. The units would be 15 hot dogs to 9 minutes. The slope would be 15 over 9. When we drive to Fort Worth, we drive 36 miles in 25 minutes. Real quick, I want you to say to yourself, I want you to fill that out real quick in your own time. Pause video, fill it out. I hope you pause video because I'm keeping it pushing. All right, so we're looking at our units being 36 miles to 25 minutes. Therefore, our slope will be 36 over 25, right? Our rate would be 36 divided by 25, which is 1.44. 1.44 the rate. Units, we said 36 to 25 minutes. Slope is 36 over 25. In 5 hours, a dolphin can travel a distance of 135 kilometers or kilometers, whatever you want to say, whatever floats your boat, works for me. So remember, anytime you see time, that's going to be at the bottom of the ratio. Our units will be 5 hours and 135 kilometers. Our slope would be 135 over 5 because 5 is measured in hours and that's time. Remember, time always is at the bottom of the ratio. So we end up with 135 divided by 5 and that answer is 27. Let's move it on. Moving on. Moving on. I'm not gonna talk about this one. A butterfly can travel 30 miles in 1 hour. Your slope is going to be 30, right? Because 1 hour over 30. 30 divided by 1 gives you 30. Let's talk about this. Okay, so it says a butterfly can travel 30 miles in 1 hour. Using the slope from above, which graph matches the distance? All right, I want you to determine for briefly which graph matches what was just said here. All right. I hope that you looked at it. Did you guys look at this and say that it's this one? No. This ratio is 30 to 5. 30 to 5 reduces to 6 because 30 divided by 5 is 6. 6 will be the slope of this graph. Did you look at this one? Oh, there's 1 in 30. No. No. That's 1 over 30. Remember we said rise over run. Rise over run. That will be 1 over 30. The slope to this would be 30. The rise over run here, the rise would be a rise of 30, a run of 1. 30 over 1 reduces to 30. There's your answer. I wasn't going to go over this, but I will go over this. Triangle MNP and triangle JKL are similar triangles. What is the proportion of the slope of segment LJ to the slope of MP? So we're talking about LJ, that's this one, and we're talking about MP. First of all, if the hypotenuse of these triangles are, if the hypotenuse of these triangles are on the same line, then the slope is going to be the same. So it's asking, what is the ratio? Well, the ratio would be, let's see, we're going from JL, that's a rise of 1, 2, 3, 4, and a run of 1, 2, 3. All right, now this slope is a negative slope because it's going downwards. So the slope here, this will be 4, a negative 4 to 3. And if we're looking at MP, that is 1, 2, 3, 4, 5, 6, 7, 8. Still going, 9, 10, 11, 12. 12, right? Over 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 12 over 9. 12 over 9, both of those are divisible by 3. 12 divided by 3 is 4. Let me go back. I want to pause this because I want to show this to you, and I'm going to wrap this up. I just wanted to show you guys this so that you understand what I'm saying. Y'all saw me do the rise over run, and we ended up with 12 over 9. Well, check this out. 12 divided by 3 is 4. 9 divided by 3 is 3. Therefore, the slopes of these, as I said in the beginning, is the same. Okay, I just wanted to show you that because I didn't want to just talk you through it and you not thoroughly understand what it is that I'm saying. Let's go back to our assignment. And I think that from here, we're just dealing with more of the triangles. It's telling you that my Mac is about to die. The graph shows the height of water as it fills an aquarium. Write a description that describes the rate of change here. All right, so if we're looking at this, here's our rate. We see we're here at 0. We rise 5, we run 2, right? We rise 5, we run 2. If we divide 5 by 2, you get 2.5. Therefore, the description is that the water is rising at a rate of 2.5 inches per second. All right, and I'm going to cut this video short here because you know I don't like long videos. If you guys got any questions, hit me up in the Google Classroom, and I'll catch you guys next time. Peace.